This is a continuation of partial fraction decomposition on section 6.4, and this is page 8 of your class notes. So the third example that we're going to look at is what we call as the distinct linear and quadratic factors. So when I mention these terminologies, what it's referring to are the factors. So you have x over x minus 1 times a quantity x squared plus x plus 1. So this one is your linear factor, and this right here is your quadratic factor. And this one is not factorable anymore, so it just stays as the quadratic. Okay, so I'm going to write this as two separate fractions. So you have a x minus 1 as one of the denominators, and then the other denominator is going to be 2 or x squared plus x plus 1. So remember that a fraction is proper when the numerator's power is less than the denominator. So since this is a linear in the denominator, that means that this has to be a constant up in the numerator, right? Because this has a first power, so then this has to be a 0th power, which is basically a constant. And then for this one, since this is a quadratic in the denominator, you have to have it as a linear up in the numerator. So my linear representation for this is bx plus c. Now, I don't know if you're actually going to have an x or a constant, or it could be just an x without a constant, but you need to include the bx and also the c initially because you don't know what the constants are. Okay, so first thing is I'm going to use the Heaviside method to figure out what a is. So when you let x equal 1, so for this denominator here, then I'm going to cover up this, x minus 1, and then put in 1 for all of this, all the other x's. So I get 1 over 1 squared plus 1 plus 1, which gives me 3 in the denominator. So a has to equal 1/3. Now, for the other one, I'm not able to do the finger method or the Heaviside method. And sometimes they call it as a finger method or cover up method. So what I have to do is multiply out the whole thing. So I rewrote this x over x minus 1 quantity x squared plus x plus 1. And then in place of a, I'm going to put in the 1/4 or 1/3 all over x minus 1, and then keep the bx plus c over x squared plus x plus 1 on this side, on the denominator here. Okay, so now I'm going to multiply the entire equation by the least common denominator, which is x minus 1 quantity x squared plus x plus 1. Okay, so now I'm going to distribute this to every single term. So this times this gives me x, because this denominator and this will just cancel out. And then I have this times this. The x minus 1 will cancel out, and so I'm just going to distribute the 1/3 with this. So that gives me a 1/3 x squared plus 1/3 x plus 1/3. And then I'm going to multiply this times x minus 1. So I'm going to FOIL that out. So that gives me bx squared. And then I have my outer, which is minus bx, my inner, which is plus cx, and last is minus c. Okay, so now I'm going to match up the terms. So if I first look at the squared term, I have no squared term on here, so it's going to be a 0. Here's a squared term, and I'm just going to strip off the x squared, so it's 1/3. And here's another squared term, and that is going to equal, hold on a second. Actually, I think I did my constant first. All right, let me go back. So for my constant, I have 1/3 and then a minus c. So it's a 1/3 minus c, and there's no constant on this side, so that's going to be 0. Right, so then when I solve for c, I get c is equal to 1/3. Okay, now I'm looking at the squared term. So there's no squared term on this side, so it's going to be 0 equals, and here's a squared term, which is 1/3, and here's a squared term, which is plus b, so b is equal to a negative 1/3. All right, so then with that, I can substitute it all back into this. So then I end up with a 1/3 over x minus 1. And then my bx plus c is a negative 1/3 x plus 1/3 all over x squared plus x plus 1. And that's the partial fractions. Okay, for the fourth example, I have what's called a repeated quadratic factors. So x squared plus 4, and then it gets squared. So just like the repeated linear, I need to account for both of the powers. So I have a x squared plus 4 and also an x squared plus 4 squared. So if the denominator is a square, then that means the numerator, or quadratic, that means the numerator has to be a linear. And then same thing with this. So I'm going to use ax plus b in the numerator here, and then a cx plus d in the numerator here. Okay, so the finger method, or the Heaviside method, will not work on this. So then I'm just going to have to multiply through by the least common denominator. So you have x squared plus 4 and then squared. Okay, so then multiplying all that out, this times this, these cancel out with the x squared plus 4 to the second power, so I get 2x squared plus x plus 8. And then if I multiply this times this, one of the x squared plus 4 will cancel out. So then I have ax plus b, quantity x squared plus 4. And then with this one, they both cancel out, so I get a cx plus d. Okay, next I'm going to FOIL everything out on the right-hand side. So the left side stays the same, and then on the right side I have ax squared plus 4ax, that's this times this, plus bx squared, that's the inner, and then the last term is 4b, and then cx plus d. Okay, now I'm going to match up all of the terms. Okay, so the first thing I'm going to match up are my x squares. So I have no x squares on this side and an ax squared on this, or I'm sorry, cubes. So I have no cubes on this side and I have a cube on this side. So then a is just going to equal 0. Next one is a square, so that's 2x squared. So then it'll just be 2. And then I only have an x squared here, so b is going to equal 2. Okay, so you're just matching up your powers at this point. And then I have x's I'm on now. So 4a, and then here's an x, which is a plus c, and then this one is an x, so that is equal to 1. Right? So I just stripped off the x. And now I'll do a little bit of back substitution. So since a is 0 from this, I have 4 times 0 plus c is equal to 1, so c is equal to 1. Okay, so the next thing is the constant. So I have 8, and then it's 4b plus d is equal to 8. And since b is equal to 8, b is equal to 2, then it's going to be 8 plus d is equal to 8, so d is equal to 0. Okay, so then my answer when I substitute everything in is 2 over x squared plus 4 plus x over x squared plus 4 squared. Okay. The final example is an improper rational expression. So what makes this as an improper rational expression is that the numerator's power, which is the third power, is greater than the denominator's power. So since the numerator's power is greater than the denominator's power, first thing I'm going to do is to make it as a proper fraction by using long division. Okay, so this is called the dividend. So I put the dividend in the box, and then the divisor goes outside, and then I'm going to match up my power. So my first term is x. So x times x squared is x cubed, and then I have to distribute this. x times x is plus x squared, and x times negative 2 is negative 2x. And then you have to subtract. So put this in parentheses. It's very easy to just negate the first term and not the other terms, right? So you're going to negate everything. So this drops out. This becomes a minus x squared, and then this is going to be a plus x, and then I drop down the 3. Okay, so since this is called the remainder, so if the remainder's power is still the same as the divisor, then I have to still do more dividing. So then I'll have a minus 1 up on top. So I distribute this through. That gives me a negative x squared minus x plus 2. Okay, then I'm going to subtract everything. So if I subtract that, this gives me a 2x, and then 3 minus 2, which is a 1. So this right up here is your quotient. So I'm just going to rewrite that separately. And this is my remainder. So this right here is my remainder. And then I'm going to put the remainder over the divisor, and that'll create my proper fraction. Okay, so I have a 2x plus 1 from the remainder here, and then in the denominator, I just factored this, right? So you get a x plus 2 and an x minus 1, and then I split it up, so I have a over x plus 2 plus b over x minus 1, and then I'm just going to use the Heaviside method. So when x is equal to a negative 2, then I'll cover up this one here, so that gives me negative 4 plus 1, and then I have over a negative 2 minus 1, so a is equal to 1. And then with this one, I let x equal 1, and so if I cover up this one here, then I have 3 over 3, which is 1. So both a and b are 1. And then my final answer is x minus 1 from this, and then a is 1, so it's plus 1 over x plus 2 plus, and then b is a 1 over x minus 1.